Hi guys, it's Mrs. McInnes here. Welcome to lesson 8 of our Trig part 2 topic. So today what I'm going to concentrate on with you is looking at past paper style questions, assessment style questions involving our sine and cosine rules. So what I've done is I've actually chosen a few questions from the Unit 4 booklet and added these into my notes here. So these will not be in your actual printed notes, but if you can maybe make a note of them as I go through, or even just watch them and then you can kind of go on with the questions later on, that would be fine as well. So here, the first question I've chosen that I would like to go through to you is a really important style of question because this one comes up quite often in assessment questions, past paper questions. And it actually involves the trig that we've been learning right now, but also it brings into the question a bit of SOHCAHTOA. So that would be previous learning from trig that we've looked at with right angled triangles. So the question says 2 security cameras are positioned on a beam in a warehouse 30 metres apart. So that is that long horizontal side along the top being 30 metres, and at either side there's a security camera. So one camera has an angle of depression of 37 degrees. That just means from that horizontal plane pointing down the way 37 degrees. So that's the one on the right. And then the other camera has an angle of depression of 46 degrees. So that's the one on the left. So it says here, calculate the height in metres of the beam above the ground. So that's been marked onto this diagram for you here as that vertical line H. So if we think, what do we have on the picture? What do we need? What can we use? So you're being asked to find that vertical height. So actually that vertical height blocks off this into 2 right angle triangles. So I'm actually just going to block off this first one here. So on this side here, that there would be a right angle triangle, okay, because you have that vertical height coming down. So in that triangle, if I wanted to find that height, what I would use is SOHCAHTOA because it's a right angled triangle. So to use SOHCAHTOA, you need to have an angle and one of your sides to then find a missing side. So this side here, if I find that side there first, then I can just do a wee simple SOHCAHTOA in that right angled triangle to find that vertical height. So if we think of the bigger picture here now, that side that I've drawn the arrow to, I need to find that side in my triangle first of all. So in the triangle we've got 2 angles, so we could fill in the third angle. We might need it, we might not, but we might as well fill it in. So if we fill in that third angle, we would be doing 180 minus 46 minus 37 as well, which is going to leave us with 97 degrees. So that angle just down there in that corner there is 97 degrees. So in this triangle, I've got my 3 angles now, and I've got one side, and I'm trying to find that side where the red arrow is. So what we'll do is we'll label the triangle. So we'll give it our capital letters. So we'll call that side A, straight across small a. We'll go for B up the top here, and straight across would be small side B, and then capital C and small c. So we'll label the triangle and we'll see if we have what we need to use sine rule. First of all, that's what I was telling you to check for first. So if we look at what we have, so we have A over sine A equals B over sine B equals C over sine C. So in the triangle, we have all the angles. We have side A and we're trying to find side B. So I do actually have what I need to do the sine rule. So let's go ahead and fill in our values now. So side A is 30, so it's 30 over sine 97 equals B is the side I'm trying to find, so I'll leave that as a B over sine 46. We're then going to cross multiply, starting with the value that we're looking for. So I'm going to do that side first. So B times sine 97 equals 30 times sine 46. And then to find B, we're dividing by sine 97. So 30 times sine 46 divided by sine 97. Remember in your calculator to close off those angles just so that it does the calculation correctly. So for side B, we're going to get an answer here of 21 points. I'm going to round it to one decimal place, so 0.7 metres. So if I now go back to the right angle triangle in red that I had drawn out to begin with, this side here is 21.7 metres. So in that triangle, if we isolate that triangle, we have 21.7 metres. We have 37 degrees at the top, and we're looking for this side H. So in that triangle, from the angle that I have filled in, I have my opposite side, so that's the side straight across from your angle. The long slanted side across from the right angle is your hypotenuse, and then the side that's left over is your adjacent. So if we just have a quick look at SOHCAHTOA as a little reminder, we have our hypotenuse, and I'm looking for my opposite side. So the one that has two letters highlighted is the one that you would use, so it would be sine, S-O-H. So sine of 37 is equal to the opposite side, which is h, over the hypotenuse, which is 21.7. Okay, so remember, sine x is equal to opposite over hypotenuse. So to find my height has been divided by 21.7, so I would times both sides by 21.7. So as a height here, as I'm going to go for one decimal place, we're going to get 13.1 metres. Okay, so that style of question you will see at various points through the rest of this topic. That little trick of using SOHCAHTOA in the right angle triangle, you will see that, and if you don't really remember how to do that, you can let me know, drop me a little message, and I can always send out some extra revision for SOHCAHTOA. But I think you will remember it as we go through these questions, as we practice these questions. It will come back to you if you're not terribly sure on how to fill that in. It will come back to you. We have done it before. So the next question I've chosen for you is this one here, which is question 6. So here we have a triangular sail that's designed for a racing yacht shown below. We've got two of the edges measuring 6 metres and 3.2 metres. So we're told here that the perimeter is 15.5 metres, and we're asked to calculate the area of the sail. So what we need to think about is, okay, we're being asked for the area of the sail. So to do area, we need two sides with the angle in between. So we have two sides on here, but we don't have the angle in between. So what you need to do is you need to find that angle first before you can do the area calculation. Then we need to think, well, why have we been told that we've got a perimeter of 15.5? What would that be for? Well, obviously that would be for filling in that third side. So if we do 15.5 minus 6 minus 3.2, that leaves that third side as 6.3 metres. Now that we have all three sides of this triangle, we can now go ahead and find the angle that we need to do the area calculation. So let's first of all label the triangle. So we'll go for A and B and C. So I'm going to go for finding this angle down here at A. Okay, because if I have the angle and the two sides either side, we can do area. You could actually choose to find any angle in this triangle, any one at all you can find, because you have all three sides, and then you can use the two sides either side of the angle that you choose to find. So any angle would work here. I'm going to go for finding the one that's marked as A. So the formula that you would use here, so if you tried to do your sine rule, you don't have another angle, so you wouldn't have enough information to use your sine rule. The only one that works for all three sides is your cosine rule. So cos A equals b squared plus c squared minus a squared over 2bc. So if we go ahead and start filling this in, side B is 6, so we've got 6 squared plus 3.2 squared minus 6.3 squared over 2 times 6 times 3.2. So when we put that into the calculator, we're going to get as our decimal answer here 0 point, and I'm just going to write the first few numbers, so 1705 dot dot dot. So for A, we would do inverse cos of that value, so 0 0.1705 dot dot dot. Remember to use shift cos and the answer key. Use that answer key when you're typing this in the calculator to make it the most accurate answer that you can. So here I'm going to go for, I'm just going to go for the nearest whole angle, so 80 degrees. So now that you have that angle, you can now do your area calculation. So if I put 80 degrees onto the picture here, then I have what I need to do my area calculation. So area equals half AB sine C. Now in this case, the angle that I have is at A. So if I just rewrite that, it would be half BC sine A. So I would put in the values, half times 6 for B times 3.2 for C times sine of 80, which is the angle I just found. And as my answer, I'm going to go for 2 decimal places here. Just that's how I feel like I would want to round this to. So 9.45. And your units would be meters squared because it's an area. Okay, if the question doesn't specify how to round your answer, you can just choose how you want to round it. 1 decimal place or 2 decimal places would be fine. Okay, the next example that I have chosen for you to do here is quite a long example, so we'll go through it in stages. And really this is going to bring together a lot of different pieces of the previous work that we've looked at. So question 8 here, we have a diagram showing a steel plate ABCD. We've got AB 16 centimetres, A to D is 18 centimetres, and we've got the little right angle at DAB, so that's just marked on there. We also have this 44 degrees on the outside as an exterior angle. So the first part of the question is asking us to find the length of BD to 1 decimal place. So BD is the long side of a little right angle triangle. So really that's Pythagoras we're using here. So BD squared will be equal to 16 squared plus 18 squared. So that's the long side we're finding, so we're squaring and adding. So 16 squared is 256, 18 squared is 324. So if we add those together, we get 580. So BD would be the square root of that answer. So square root of 580. And the answer was to be to 1 decimal place. So we would have here 24.1 centimetres. So that's part A, that's just Pythagoras, should be a really straightforward question to do. Part B is then to find the size of angle BDC. So that would be that angle just marked there. So following those letters, BDC is that angle down there. So what I'm going to do is I'm going to write onto the picture what I just found, 24.1 for this long side here. So 24.1 centimetres. So in that triangle, we need to think about how could we find that angle there. So if you look at triangle BDC, we only have one side of that triangle. So we don't have enough information in that particular triangle to use sine rule or cosine rule to find the angle that we're looking for. But what we do have is the 44 degrees on the outside and a right angle triangle on just the left hand side there as well. So you've got to think, well, why would that 44 degrees be there? I need to use that in some way. So if we actually find the angle just here in red, what we could do there is do 180 for a straight line and then subtract that red angle and subtract the 44 and we'd be left with the angle that we're asked for. So in the right angle triangle that we have there, so if I just isolate that out of the diagram, we have 18 at the bottom and we have 16 at the top. So we could just use that and actually just use SOHCAHTOA. We do have the third side, but I'm just going to use those two for now. So in the triangle, the angle we're looking for is this one down the bottom, which is X. So if you write out SOHCAHTOA, in that triangle, what I do have is straight across from x is my opposite side, and the long side is your hypotenuse, and the side that's left is your adjacent. So in that triangle, I've got the opposite side, so the O, and I've got the adjacent side, which is the A. So in this case, I'm going to use tan because it's TOA. So tan x is opposite over adjacent. So tan x will be equal to 16 over 18. So to find x, we would just do inverse tan of that value. So x equals inverse tan of 16 over 18. So on the calculator, that gives you, I'm going to go for the nearest whole angle, so 42 degrees. So if we go back to the original picture, we have 42 degrees in the little red bit. We have 44 on the outside. So we can now find that angle that we were looking for, BDC. So I'm just going to make sure I write that here. So angle BDC would be 180 minus 42 minus 44, which gives us 94 degrees as the angle that we were asked for. Okay, part C of this question, if I just scroll this back up, so 94, I'm actually just going to write that onto here as well, so 94 degrees. So part C of the question says, hence calculate the length of BC, given that DC is 25, so DC is not written on there, but you could fill that in now, so we've got 25 centimetres for that side there. So in this picture here, we now have two sides of this triangle, and we have the angle that's in between. So we could look and see, do we have what we need for sine rule? So we're looking for side B to C, so we would need another angle in that triangle BCD to have what we need for sine rule. We would need another angle. So we don't have what we need for sine rule. We do have two sides with the angle in between. So that is what we need for using cosine rule. So it's going to be the cosine rule that we use. So in that triangle, we've got capital letters already. So if we fill in small case letters straight across from each side, we can set up our cosine rule. So we're looking for BC, which I've labelled with a small case letter D. So the way I would set up my formula would be D squared equals, and it'll be the other two letters, so B squared plus C squared minus 2BC cos D. So in here, side B is 25, so 25 squared plus 24.1 squared minus 2 times 25 times 24.1 times cos of the answer that I just filled in, so 94 degrees. So when you put all that in your calculator, you get 1289.866 and so on. And then to find D, because remember this is D squared, so to find D we would square root that answer, that last answer. And remember, use that answer button on your calculator so that you get the full value put into the square root. So I'm going to go for 1 decimal place here, so 35.9, and this is a length, so it's meters. Okay, so that question is a long question. There's lots of different elements to that. We've got Pythagoras, we've got SOHCAHTOA, we've got cosine rule. If you can manage to follow that question and complete that question, then I would be saying you should be feeling quite confident about your skills in these various areas of the topic. Okay, there's one last question that I've chosen for you to do, which is quite a bit shorter than the last one. So here we have in triangle PQR, we've got PR is 10 centimetres and QR is 4 centimetres. And we've got the perimeter of the triangle is 22 centimetres. Find the size of angle PQR. So PQR is this angle up the top. Now the first thing I'd want you to notice here is that is an obtuse angle. That angle is clearly bigger than 90 degrees. So maybe just sort of make a little note of that for yourself, and just remember as you go through that that's an obtuse angle. You can tell that from the picture. So we have a perimeter of 22 centimetres. So to be able to find the missing angle, If we wanted to use sine rule, we would need the angle at P so that we had the matching pair. We don't have that and there's no way to fill that in. So you would be using your cosine rule to do this. So for cosine rule, you need all three sides, which is why you've been told the perimeter is 22. So the first thing we would do is fill in that third side. So 22 minus 10 minus 4 leaves us with 8 centimetres. So we would fill that in as that missing side. So to find the angle at Q, we're going to be doing cos Q equals, and it's the other two letters that go first. So P squared plus R squared minus Q squared over 2PR. So if we pop onto the diagram the little small case letters, we can now fill this in to the formula. So cos Q equals, so P is 4, so it's 4 squared plus 8 squared minus 10 squared over 2 times 4 times 8. So here we get minus 0.3125 exactly. Now, this is the other way you would know that your angle's obtuse, because we've got a negative value here for cos. So when we work out what Q is, we're going to do inverse cos of just the positive value, so 0.3125. So we get an answer of 71.8 degrees. So that would be your related angle. So to find angle PQR, we would need to do 180 minus that related angle. That's essentially the same thing as giving us the answer in that second quadrant of our cast diagram. So in that section there, because cos is negative, and remember I said you can't get an angle bigger than 180 in your triangle. So in this section it's your 180 minus that related angle. So our final answer here is going to be 108.2 degrees. Okay. So I know this is a long video, so similar to the other day with the mixed questions, I don't expect you to get a lot of the questions started today. By the time you watch this video and you follow through the steps of working that I've done in these 4 questions, but make a start on this if you've got the time to, and we will also spend our next period on this as well. So in the booklet, I've chosen questions for you that I'd like you to do. So page 36, question 1, 2, 4, 5, 7, 10 and 14. These are all exam style questions on sine rule, cosine rule, area of a triangle. So make a start on what you can today, and we will continue these on in the next lesson as well. Okay, I will be on the Teams page today on the live call. It will be open if you want to come on and ask me any questions. If there's anything from those examples that you didn't understand or didn't follow or just have questions about, please come on the live call and just ask me. And I'll be there for the whole period if you need any help. Okay, thanks so much for listening, guys. I know this is a long video, and I'll speak to you all on the Teams page. Okay, thanks. Bye.